Okay, so for the last part of our discussion today, we'll have the evaluating functions, operations, and composition of functions. Okay, so first off, let's have the evaluation of functions. Okay, so given that we have here a function 2x cubed minus 3x squared minus 5x plus 2, let's find if x is 1, x is negative 1, and x is negative 1 half. Okay, so here, actually, when it comes to evaluating functions, all we need to do is to substitute, okay, the values of x here. So first off, if x is equal to 1, so let's substitute that to our function. So we'll have here 2 times the 1 cube minus 3 times 1 squared minus 5 times 1 plus 2. If we're going to simplify this, we'll obtain negative 4. Okay, so if x is equal to 1, then the function is equal to negative 4. Another one, if it is negative 1, if x is equal to negative 1, we'll have 2 times the quantity of negative 1 cube minus 3 times the quantity of negative 1 squared minus 5 times the quantity of negative 1 plus 2. Okay, and then if we're going to simplify this, we're going to obtain the value of 2. Okay, so if x is equal to negative 1, the value of the function here is 2. Then lastly, if we're going to substitute negative 1 half, we'll have this set up. We'll have 2 times the quantity of negative 1 half cube minus 3 times the quantity of negative 1 half squared minus 5 times the quantity of negative 1 half plus 2. Okay, so if we're going to simplify this, the result is 7 halves. Okay, so if x is equal to negative 1 half, then the function is equal to 7 halves. Let's have another example. So given that we have here the function b minus b squared all over 1 plus b squared. Let's try to find the values of our function given that the b is negative 1 half, negative 2, and negative 1. Okay, so if you want to try to answer this, you can pause the video and you can resume it after you answer the three items. Okay, so let's start first with negative 1 half. If we're going to substitute negative 1 half here, we'll have this set up. Negative 1 half minus the quantity of negative 1 half squared over 1 plus negative 1 half squared. So if we're going to calculate this, the result is negative 3 fifths. Okay, so we have negative 3 fifths. Again, and also if we're going to substitute negative 2, we'll have this. Negative 2 minus the quantity of negative 2 squared all over 1 plus negative 2 squared. And if b is negative 2, then the function is equal to negative 6 over 5. Okay, the answer here is negative 6 over 5. Then lastly, if we have b is equal to negative 1, let's substitute. We'll have negative 1 minus the quantity of negative 1 squared over 1 plus quantity of negative 1 squared. So given this, if b is equal to negative 1, the answer here is also negative 1. So as you notice from the two examples that I have presented, all you need to do is to substitute and perform the arithmetic. Let's have another example. Okay, so given that the function here is equal to 1 over x, show that the function of f of a is equal to f of b is equal to f of ab all over b minus a. Okay, so let's see. So as you notice here, I forgot to have the animation, but let's try to discuss this one. Okay, so given that we have here f of a times b all over b minus a, let's just substitute. Okay, this one to x. So as you notice, given that the function here, the f of x here is 1 over x. Okay, so given that this is 1 over x, let's just replace x by this. AB all over b minus a. So as you notice, given that we have 1 over x, we'll have this. 1 over AB over b minus a. Okay, then as you can see, let's just reciprocal this one. Okay, and we'll obtain b minus a all over a times b. Okay, then let's separate this one into fractions. So we'll obtain b over a times b minus a over a times b. Then let's simplify. So given here we have common factor of b. And then here we have a common factor of a. So with that, we'll have 1 over a minus 1 over b. Then notice, given that we have here 1 over a minus 1 over b, if we're going to use this f of x is equal to 1 over x, we'll obtain this function. We'll obtain this function f of a minus f of b. Okay, so therefore this 2 is equal. Okay, so given the difference of f of a to f of b is equal to the function f of a times b all over b minus a. Another example. If the function, if we have f of x plus 1 is equal to f of x is equal to 3x plus 2, find f of 2021 minus f of 2020. Okay, you can pause the video again so that you can solve this problem. Okay, and then you can resume it when you are done. Now, here, notice that we have 2021 and 2020. Okay, let's relate that here in the given function f of x plus 1 minus f of x. So let's say if we're going to have x as 2020, obviously this function, this one, we have 2020 plus 1, which is 2021. Okay, so let's say we let x be equal to 2020. Okay, so let x be equals to 2020. So if we're going to substitute that to our function, we'll have f of x plus 1 minus f of x is equal to 3x plus 2. And then since x is equal to 2020, we'll have this. F of 2020 plus 1 minus f of 2020 is equal to 3 times 2020 plus 2. Okay, and as you can see, we have here 2020 plus 1, which is 2021. And then we have f of 2020, which is this one. Okay, which is our problem. So let's try to simplify right hand side to solve for this value. So given that we have 3 times 2020, so 3 times 2020 is 6,060 plus 2, and 60,060 plus 2 is 6,062. So as you notice, we have here the f of 2021 minus f of 20 is equal to 6,062. Okay, let's have this last one. So what is f of 2 plus f of 1 minus f of negative 3? If the given function here, we have a piecewise defined function we have three subfunctions here. The first one is 3x squared plus 2x minus 1, given that x should be greater than 1. And then another one, we have your 3 minus 2x if x is between negative 3 and 1 inclusive. And then lastly, the third subfunction, we have negative x squared minus x if x is less than or equal to negative 3. Okay, so as you notice here, when we evaluate a piecewise defined function, all we need to do is to identify the subfunction that we're going to substitute the value of 2, 1, and negative 3. So let's start first with 2. Let's observe all the domain here on each subfunction. So as you notice here, we have x is greater than 1. So since x is greater than 1 here, obviously 2 is included. Okay? So with that, let's substitute 2 in the first subfunction. So if we're going to substitute that, we'll have 3 times 2 squared plus 2 times 2 minus 1. And if we're going to simplify that, the answer here is 15. Okay, the answer here is 15. And then, how about 1? Which subfunction should we use here? Since the first subfunction, the domain is x is greater than 1, so obviously it's not. How about the second subfunction? So given that the second subfunction is greater than negative 3, but less than or equal to 1. So with that, let's try to substitute 1 to the second subfunction. So we'll have 3 minus 2 times 1, and 2 times 1 is 2, so 3 minus 2, the answer here is 1. Then lastly, we have your f of negative 3. Okay, so negative 3 is on the third subfunction because we have your x is less than or equal to negative 3. So with that, let's try to substitute. Okay, so we'll have negative times the quantity negative 3 squared minus negative 3. And if we're going to simplify that, the answer here is negative 6. Okay, and here we are not done yet. Okay, we're going to identify the sum of f of 2 and f of 1, and we subtract it with the result of f of negative 3. So with that, we'll have f of 2 plus f of 1 minus f of negative 3 will have 15 plus 1 minus negative 6. And 15 plus 1 is 16 minus negative 6. 16 plus 6, that is 22. Okay, so the answer here to this problem is 22. Now, how about the operations on function? Okay, so when it comes to operations of function, actually it's the same with the idea of the operations on the polynomials with algebraic fractions. We're just going to apply it, but this time we are dealing with functions. We are dealing with the function. So we have four basic operations. We have the sum, the difference, the product, and the quotient. Okay, so notice that here in our quotient, we have a restriction that the denominator, the function, should not be equal to 0 because this will become undefined. So let's apply. Find the addition, subtraction, division, multiplication of the two functions. So given that we have f of x is equal to x squared minus 1 and g of x is equal to x plus 1. So first off, let's try to identify the sum. So we have here x squared minus 1 plus x plus 1. Okay, so if we're going to simplify that, we'll have x squared plus x. So as you notice, we have here negative 1 plus 1 is 0. So the sum of that two functions is x squared plus 2x. And then for the difference, okay, let's have the difference. Don't forget to put the parenthesis here, and we're going to distribute that minus sign here. Okay, so given that, we'll have x squared minus 1 minus x minus 1. Okay, then we have here x squared. We have negative x. Then we have negative 1 minus 1, which is negative 2. So therefore, the difference is x squared minus x minus 2. Next one for the product. Okay, all we need to do is to apply the FOIL method. And we'll obtain x cubed plus x squared minus x minus 1. And then lastly, for the quotient, we have x squared minus 1 divided by x plus 1. So as you notice, we can factor the numerator here. It is a difference of two squares. And x squared minus 1, we can express that as x plus 1 times the quantity of x minus 1. So as you notice, as you observe, there's a common factor here of x plus 1. Okay, so if that's the case, our answer here is x minus 1. Okay, so the quotient here is x minus 1. In addition, let's have this problem. Okay, so it's the same, but this time we're going to identify specific values. Given that the sum, let's identify if x is equal to 2. And then for the difference, if x is equal to negative 3. For the product, if x is equal to negative 2. And then for the quotient, if x is equal to negative 5. So let's just get the result from the previous slide. So first off, let's have for the for the sum. So given that the sum is x squared plus x, let's just substitute 2. Okay, so if we're going to substitute 2, we'll have 2 squared plus 2. 2 squared is 4. 4 plus 2 is 6. Okay, so we have here f plus g of 2. The answer here is equal to 6. And then for the difference, let's have here the result is x squared minus x minus 2. Let's substitute negative 3. So we'll have negative 3 squared minus negative 3 minus 2. And then if we're going to simplify that, we'll have 9 plus 3 minus 2. And 9 plus 3, that's 12. 12 minus 2, that's 10. Okay, so f minus g of negative 3, the answer here is 10. And then for the product, given that we have x cubed plus x squared minus x minus 1, let's just substitute negative 2. If we're going to substitute negative 2, we'll have negative 2 cubed plus negative 2 squared minus the quantity of negative 2 minus 1. And then if we're going to simplify that, we'll have negative 8 plus 4 plus 2 minus 1. And the answer here is negative 3. So the product of the functions f and g of negative 2 is negative 3. Then lastly, for the quotient, f divided by f over g of negative 5. So given that we have the quotient x minus 1, let's just substitute negative 5. And negative 5 minus 1 is negative 6. Okay, the answer here is negative 6. Okay, here, actually, you can replace this x as 2. Here, you can replace this as negative 3. This one, you can replace this as negative 2. Okay. Another one, Given that the function is x squared plus 3x plus 2 and x plus 2, let's identify the following. So let's start first with the sum, and then if we're going to substitute x is equal to 2. Okay, so identifying its sum, we'll have x squared plus 3x plus 2 plus x plus 2. And the result of that is x squared plus 4x plus 4. And then if we're going to substitute x is equal to 2, we have 2 squared plus 4 times 2 plus 4. The answer here is 16. Okay, so 2 squared, that's 4. 4 times 2, that's 8. 4 plus 8 plus 4 is 16. How about this one? Okay, again, you can pause the video and then you can solve this. So identify the difference, f minus g of x, and then if we're going to substitute x as a is equal to 1. Okay, so if we're going to substitute that, we're going to subtract this. We'll have x squared plus 3x plus 2 minus the quantity of x plus 2. Okay, and then if we're going to identify its difference, the difference for that is x squared plus 2x. And then here, if we're going to substitute x is equal to 1, we'll have 1 squared plus 2 times 1. 1 plus 2, the answer here is 3. Okay, the answer here is 3. Another one. So given that we have the product of f and g, and then if x is equal to negative 1. So again, for product, we just need to multiply the two functions. We have x squared plus 3x plus 2 times the quantity of x plus 2. And the result of that, the product of that is x cubed plus 5x squared plus 8x plus 4. And then let's substitute if x is equal to negative 1. We'll have negative 1 cubed plus 5 times negative 1 squared plus 8 times negative 1 plus 4. And the answer to that is 0. Okay, that is 0. Then lastly, identify the quotient f divided by g of x, and then if x is equal to 3. Okay, so here again, we're just going to divide this. And as you notice here again, here in our numerator, x squared plus 3x plus 2 is factorable. Okay, we can have the other types of trinomial, and we can observe the factors here are x plus 1 and x plus 2. Okay, we have the factors x plus 1 and x plus 2. And again, there's a common factor of x plus 2. So since there's a common factor of x plus 2, all you need to do is to cancel that. We'll have 1. So the result of that, the quotient here is x plus 1. Then lastly, if x is equal to 3, so 3 plus 1, the answer here is 4. Okay, so as you can see here, for the operations on function, we just perform the indicated operation, the addition, subtraction, multiplication, and division. And also we can evaluate. Okay, we can also evaluate here. Okay, for the last one, we have here composition of function. Okay, so in the composition of the function with f and g is denoted by this f circle g and is defined by the equation f circle g of x is equal to f of g of x. Okay, f of g of x. So the domain of the composition of the function is the set of all x such that x is in the domain of g and g of x is in the domain of f. So let's try to apply this. Okay, in this example. So find f of g of x for f of x is equal to the square root of 2 minus x and g of x is equal to 3 minus x. Let's find f of g of 2 and f of g of negative 2. So first off, let's try to identify the composition of function f of g of x. Okay, so here we're going to take g of x as our x. Okay, again, this g of x as our x. So let's substitute that g of x, which is 3 minus x, to the x of our function f. Okay, let's just substitute that. Okay, so the f of g of x here is f of 3 minus x. Okay, it's the same as f of 3 minus x. So if we're going to substitute that, we'll have square root of 2 minus, let's substitute that to x, we have 3 minus x. And then let's simplify, 2 minus 3, that's negative 1. And then distribute that negative, we'll have positive x. So therefore, we have f of g of x is equal to square root of x minus 1. Okay, we have here the square root of x minus 1. Now, so given that, let's try to solve for f of g of 2 and f of g of negative 2. So, let's start first with f of g of 2. So, f of g of 2 will have here x minus 1. So, 2 minus 1, that's 1. The square root of 1 is 1. Okay, how about if we have here negative 2? If we're going to substitute here negative 2. Okay, so if we're going to substitute negative 2, actually we'll have a imaginary. Okay, so if that's the case, there's no solution for f of g of negative 2. Okay, there's no solution because if you're going to identify the domain of this function x minus 1, the x should be greater than or equal to 1. Okay, if it is negative 2, obviously the answer here is there's no solution. Okay, the answer is imaginary. Let's have another one. Given that f of x is equal to 3x minus 4 and g of x is equal to x squared plus 6, let's find the following. F of x and f of 2. So as you notice, the x value here is the function itself, 3x minus 4. So if that's the case, if we're going to identify the f of x, we'll have f of 3x minus 4, which is equal to 3 times 3x minus 4 minus 4. Okay, so as you notice, we're just going to substitute 3x minus 4 as our x here in the function f. And then if we're going to simplify that, 3 times 3x, that's 9x. 3 times negative 4 is negative 12. So therefore, f of x is equal to 9x minus 16. Lastly, we have here f of 2. So if we have f of 2, we're going to substitute that as our x. So 9 times 2, that's 18. 18 minus 16, the answer here is 2. So the f of 2 is equal to 2. Next one. Find the f of g of x. Okay, find the f of g of x. Okay, so as you notice here, we have that f of g of x. Actually, this is quite easy because we identified first the f of f. Provided that we have that f of f as 9x minus 16, we can just substitute that g of x to the result of f of x. Okay, so let's just substitute x squared plus 6 to our f of f. Okay, let's just substitute that to our f of x. So if that's the case, we'll have this. We'll have 9 times the quantity of x squared plus 6 minus 16. And then if we're going to simplify, 9 times x squared is 9x squared. And then 9 times 6 is 54. So 9x squared plus 54 minus 16. And 54 minus 16, the answer here is 38. So therefore, the f of g of x is equal to 9x squared plus 38. Okay, the answer here is 9x squared plus 38. Last one. Okay, let's have this last one. Given that the function is equal to 3x minus 5, f of x is equal to 3x minus 5, and the g of x is equal to 2x plus b. Okay, so find b. Okay, find b such that the f of g of x is equal to the g of f of x. Okay, the f of g of x is equal to the g of f of x. Okay, so with that, again, you can pause the video so that you can answer this first before checking, verifying if your answer is correct. Okay? So, given that we have f of g of x and g of f of x, let's try to solve that first. Okay, so first off, let's have that f of g of x. Okay, that f of g of x. So, given that we have f of g of x, all we need to do is to substitute that g of x to our function. Okay, substitute that 2x plus v to the function f. So with that, we'll have 3 times the quantity of 2x plus 5 2x plus b minus 5. And simplifying that, we'll obtain 6x plus 3b minus 5. Okay, 6x plus 3b minus 5. And then, how about the g of f of x? For the g of f of x, this time, we're going to substitute the f of x. This will serve as our x to substitute in our function g. Okay, so we'll have g of 3x minus 5. So if we're going to substitute that to function g, we'll have 2 times the quantity of 3x minus 5 plus b. And then if we're going to simplify that, we'll obtain 6x minus 10 plus b. So as you notice here, given the condition that f of g of x is equal to g of f of x, we can just equate the two. Okay, we can just equate these two and find for the value of b. So let's just equate. We'll have 6x plus 3b minus 5 is equal to 6x minus 10 plus b. Then let's just combine like terms and identify the value of b. So if we're going to combine the like terms, we'll obtain here 6x and then another 6x here, addition property of equality. This will be 0. Okay, and then we have here 3b and then addition property of equality or just transpose. So we have here 3b minus b. And same procedure, negative 5, then transpose, that's 5. So 3b minus b, that's 2b. And then negative 10 plus 5 is negative 5. And then find for the value of b. So the answer here is negative 5 over 2. So b is equal to negative 5 over 2. Okay, in this case, all you need to do is to just follow the condition here and apply the composition of function. So basically, actually here, it's just a recall of your knowledge during your senior high school when you took your general mathematics. Okay, when it comes to introduction to the functions.